This will be for the con assignment, normal calculations in reverse. Okay, so you're going to need the z-score table for this assignment. All right, so the distribution of annual profit at a chain of stores was approximately normal, with a mean 66,000 and standard deviation 21,000. The execs conduct an audit of the stores with the lowest 20% of profits. What is closest to the maximum annual profit at a store where the execs conducted an audit? Round to the nearest $1,000. Okay, remember now, when you have the normal distribution bell curve, okay, you start at 0% on the left. All right, so the left-hand side is 0%. And as you make your way to the right, you make your way toward the 100th percentile. All right, so they are asking the maximum annual profit at the store, and they conducted the audit with the lowest 20% of profits. Okay, so lowest 20% would mean that this area to the left, and before I forget, 20% when you convert it to decimal, you move the decimal over 2 places, that is 0.20. So they're looking for the lowest 20%. So this area to the left is going to be 0.20. Okay, remember the z-score table always gives you the area to the left of that z-score. All right, so we want to look up 0.20 on the table and find the z-score associated with 0.20. All right, so the first page is the positive z-scores. And as you can see, it starts at 0.5 and just keeps getting higher toward the number 1. Okay, we said we wanted the one for 0.20. All right, so let's see if we can find it here. These are all 4 decimal places. All right, so 0.20 with an additional 2 decimal places, you just add 2 zeros. So we're actually looking for 0.2000, same thing. All right, so let's see if we can find 0.2000. Here's 0.2005. Here's 0.1977. So this is the closest one. Okay, it doesn't have to be exact, but that's close enough. 0.2005. Now we want the z-score associated with that value. So we trace this to the left, and that's negative 0.8. And we want our second decimal place. It's going to be negative 0.8. We trace this up and keep going up and keep going up. And the second decimal place is a 4. Okay, so the z-score is negative 0.84. Okay, and this area here is 20% or 0.20. So we're actually working backwards here. They give us the area and we want to find the z-score. Okay, so we're going to use z equals negative 0.84. Okay, we said z equals negative 0.84. All right, and what I am going to do is set that equal to the formula for the z-score. Okay, recall it is x minus mu divided by sigma. All right, now in the problem here, we don't have x. That's what we want to solve for. Okay, we have the mean mu, that's 66,000, and we have the standard deviation sigma, that's 21,000. Okay, so rewriting this equation, we have negative 0.84, and that's going to equal x minus mu, so that's x minus 66,000 and divided by sigma, that's 21,000. Okay? In order to get rid of 21,000 in the denominator, I have to multiply both sides by 21,000. And the same thing over here. Multiply both sides by 21,000. Okay? On the right-hand side, 21,000 over 21,000 cancels. I am going to do this part on the calculator. Okay? So on the calculator, I get negative 17,640. Okay, watch your plus minus signs. This is positive times negative, so it's going to be a negative. Okay, and on the right-hand side, I'm left with x minus 66,000. Okay, now solving for x, I'm just going to add 66,000 to both sides. Okay, on the right-hand side, 66,000 plus minus, that cancels. And I'm going to do the left-hand side on the calculator. Okay, on the calculator here, I get 48,360. That equals x. Okay, it says round to the nearest $1,000. So the nearest 1,000 would just be 48,000. Okay, and as you can see, that is answer C. All right. So to sum it up, if it says the lowest 20%, you just look up 20% on the table, find the z-score, okay, and then use the formula for the z-score to plug in for the mean and the standard deviation, and then solve for x. So basically, you're working backwards. All right, for this one here, the distribution of SAT scores of all college-bound seniors taking the SAT in 2014 was approximately normal, with a mean of 1497 and a standard deviation of 322. Certain summer program only admits students whose SAT scores are in the top 15% of those who take the test in a given year. What is the minimum SAT score in 2014 that meets the program's requirements? Okay, so once again, we're looking at our bell curve, okay, or normal distribution, because it says it was, the distribution was approximately normal, all right? And we're looking at the top 15%. Now, you have to be careful here, all right? Remember, it starts at 0% on the left and works its way up to 100% on the right. Okay, so top 15% would be about right here. Okay, and the area to the right would be 15%. All right, we know 15%. If you move the decimal over 2 places, that's going to be 0.15. Okay, so this area here is 0.15. Okay, but remember, on the z-score table, it gives you the area to the left. Okay, so we need the area in here, the z-score associated with the area in here, and that's going to be 1 minus 0.15. Okay, which is 0.85. All right, so this z-score line right here is going to be associated with 0.85, not 0.15. Okay, because the top 15% is going to be 85% and up. All right, and they want the minimum. So if we're looking at 15% and up, the minimum is just going to be this line right here. All right, so we want to find the z-score for 0.85. Let's go to the table. All right, we're looking for 0.85. And remember, the z-score table has 4 decimal places, so just add 2 zeros. Okay, so we're looking for 0.8500. All right, so here we are on the positive side, and it starts at 0.5. It keeps going up. We're looking for 0.8500. I think this is the closest, 0.8508. All right, so we just want to find the z-score for that. We go to the left, and that's a 1.0. And for the second decimal place, we go up. Okay, so it's 1.04. Okay, so the z-score right here is 1.04. All right. And that makes sense because the z-score, the chart gives you the area to the left. So we looked at 0.85, right? This area in the shaded portion is 0.85. This area right here is 0.15. Okay? They wanted the minimum value of the top 15%. So the minimum one is right here on this line. So z equals 1.04. All right, z equals 1.04. We want to write the formula for the z-score. That's going to be x minus mu divided by sigma. All right. So we start with 1.04. And that equals x, which we're going to solve for, minus mu. Okay. Mu is the mean, 1497. And divided by sigma. Sigma is the standard deviation, that's 322. Okay, now we just want to solve for x. So in order to get rid of 322 in the denominator, we multiply both sides by 322. Okay. On the right-hand side, it cancels. And on the left-hand side, I'll do this on the calculator. Okay, I got 334.88. And on this side, I'm left with x minus 1497. All right, solving for x, I'm just going to add 1497 on both sides. On the right-hand side, it cancels. And on the left-hand side, I'll do this on the calculator. And I get 1831.88. And that equals x. Okay. Now, obviously, we have to choose the closest answer. And it said, it didn't say to round, but obviously we have to round. Okay, 1831.88. I'm thinking the closest answer is answer D. All right, let me just make sure here. Okay, good. So to sum it up here, if it says lowest 20%, then you just look up 20% or 0.20 or really 0.200 on the table and find the z-score associated with that value. Okay? And for the second problem, it said top 15%. Okay? So instead of 15% or 0.15, you want to look up 1 minus 0.15, which is 0.85. Okay, so we looked that up on the table and found the z-score associated with that. All right, so if it says top 15% or something like that, subtract that number from 1. All right, so just as a quick example here it says for the shortest 5%. Okay, so 5% is the same as 0.05. Okay, and since it says the shortest 5%, that would just mean you're going to the left here. And this area is going to be 0.05. And you just look up the z-score for that value. So on this one here, it says the lower 25%. So you're just going to look up 0.2500 on the table and find the z-score for that value. All right, in this one here, it says the top 10%. Okay, so it's going to be like to the right is 10%. Okay, but the z-score table gives you the area to the left, so you want to do 1 minus 0.10, which would be 0.90. Okay, so since it says top 10%, you have to do 1 minus 10% and look up 0.90, or should I say 0.9000. Okay, and then look for the z-score associated with that value.